This video will help you understand angle sums of polygons. Completing this lab will help you understand the interior angle sum of the basic polygon of a triangle, and then use that to find the interior angle sum of any polygon, no matter how many sides there are. So we start out with a triangle, and you can take any triangle and do this activity. If you were to take it and cut it out of paper and rip the angles off, like we have this angle 1 right here, and then we rip the second angle off and the third angle off, and then you rearrange them. So we put this angle 1 right over there, and notice that we didn't measure the angle. We don't really need to know the exact measure of that particular angle, but we move it over there. We take the second one and we put its angle measure there, and we slip the third one in here. When you put them all together, no matter the size of the triangle, no matter the type of triangle, whether a right triangle or an isosceles triangle or an equilateral triangle, it really doesn't matter. If you line up the angles, they will always make a straight line, and we know that a line measures 180 degrees. So we don't know the individual angle measures, but we do know that if we measured the opening of angle 1 plus the opening of angle 2 plus the opening of angle 3, they always have to sum to 180 degrees. There's actually a name for that. That's called the triangle sum property. And so we can always remember that in any triangle, the sum of the interior measures of the angles is 180 degrees. Now we can use what we learned about the interior angle sum of a triangle to help us find the interior angle sum of any polygon. So we have some figures down below on this lab sheet, and what we're going to be doing is doing a lab or an investigation to find out what the interior angle sums of these polygons are. So we already know that a triangle has 180 degrees on the inside of it if you add up all the angles. So let's look at a square, and this would apply to any quadrilateral, but we're using regular polygons for our lab. So what I'm going to do with this square is I'm going to make a diagonal. The diagonal connects one vertex of a polygon to any non-adjacent vertex. And what I'm trying to accomplish is to divide each figure into the least amount of triangles that I can make to divide it up evenly without creating any additional angles on the inside. So for a square, I can make 2 triangles out of that square. Now, since I know that each triangle has an interior angle sum of 180 degrees, then I know I have a total of 360 degrees in my square, because 180 for the one triangle, 180 for the second triangle. Now that really makes sense to us, because if I draw another square up here, we know that one of the properties of a square is that all 4 angles are right angles. And if a right angle is 90 degrees, then 90 times 4 is 360. So that verifies what we already know about a square. So next we look at a pentagon. A pentagon is a polygon that has 5 sides. So if I take one vertex and I draw diagonals from that vertex to the other vertexes that I can divide the pentagon into 3 triangles. I'm going to number them 1, 2, and 3. And so if each of those triangles has an angle sum on the inside of 180 degrees, then the pentagon is going to have 3 times 180, or 540 degrees for its interior angle sum. Now this sort of makes sense. If you look at the triangle and it has 3 angles, they're all, in this case, acute angles, but they're all fairly small. And then as you get to a square, you have more angles, so it makes sense that the interior angle sum, adding up all the interior angles, would grow larger. And if you look at the size of each angle, they start getting larger. You look at this angle 5 on the pentagon, it starts getting wider than 90 degrees. And that's going to keep happening as the figures increase in side lengths, or in the number of sides rather. So it's fun and interesting to find out the interior angle sum of a polygon, but what we want to do is find a general rule for the interior angle sum of a polygon, because, you know, what if you had a 20-sided figure or a 15-sided figure or even a 100-sided figure? it would be very difficult to draw that and to divide it up into triangles to find the interior angle sum. So by experimenting and making an organized list, we can hopefully develop a rule that helps us with any number of sides on a polygon. So the goal of this lab or investigation is to actually fill out the table below on this lab sheet and look for patterns that will help you come up with a general rule. If you are doing this at home, you might want to pause the video from time to time and work on this and then come back to it as not to spoil the surprise for later. So let's start by working on this a little bit and make that a little larger there. And let's fill in what we know so far. So far we know that a triangle has 3 sides. There's one triangle on the inside of a triangle. And the angle sum is one triangle times 180, or a total of 180 degrees. Now this last column is not as important for the lab, but we should go ahead and fill it in. And this is assuming that these are regular polygons. Now the difference between a regular polygon and a non-regular polygon is that regular polygons have all the same side lengths and all the same angle measures, whereas non-regular don't. In the pictures on this lab sheet they do. So if we knew, for example, that a triangle had 180 degrees on the inside, each angle would be 60 degrees, or 180 degrees, the angle sum divided by the number of angles, which is the same number as the number of sides. So if we go to the quadrilateral, in this case it was a square, it has 4 sides, we divide it into 2 triangles, its angle sum was 360 degrees, or 2 times 180, and we know that each measure is 90 degrees. And so then we went to the pentagon, and the pentagon has 5 sides. We divided that into 3 triangles. 3 times 180 is 540 degrees. And when I divide 540 degrees by 5 angles, if they're all the same, they come out to 108 degrees. So you want to fill out the rest of this table, and you're looking for patterns once again. You'll notice that we only go to figure F, and then we didn't have pictures for the nonagon, which is a 9-sided figure, or the decagon, which is 10-sided. But hopefully by the time you get to that part in the table, you'll have found a pattern that'll help you decide on the angle sum without having to draw triangles and divide a figure up. So also remember that we're looking for a general rule. So as you're filling out your table, you're looking for a pattern that can help you find the interior angle sum of an n-gon. Now an n-gon is just an any-sided figure, n meaning the sides of the polygons, the number of sides. So a 15-gon would be a 15-sided figure, and a 20-gon would be a 20-sided figure. We could even use this rule for a 100-sided figure. So n just means the number of sides. And what you're trying to figure out from your pattern is how many triangles could you make inside that figure with any number of sides, and then if you knew that, could you find the angle sum of that object? So hopefully you've had a chance to work on that, and I'm going to fill in the rest of the numbers now. We have 6, 7, and 8 for the number of sides of the next figures, and the number of triangles that can be made ends up being 4, 5, 6, 7, and 8. And the angle sums are 720, 900, 1080, 1260, and 1440. Now, of, again, lesser importance, but it's interesting to find out if you had all the same measures, then a hexagon would have 120 degrees for each angle. The heptagon gets a little fuzzy. It's 128.6 roughly. And then we get 135, 140, and 144. Hopefully as you completed this lab, you noticed a couple patterns. One of the important ones is that no matter how many sides your polygon has, the number of triangles you can make by drawing diagonals through it is always 2 less than the number of sides. So the number of sides is always 2 more than the number of triangles. Let's look at that for a second. For a quadrilateral, it was 4-sided, and you could make 2 triangles. Let's just pick another one, a heptagon. 7 sides, you can only make 5 triangles, and so on. So the number of triangles is always 2 less. So if the sides were n, the number of triangles you could make would be n minus 2. 2 less triangles than the number of sides. So the angle sum is multiplied by 180 those triangles. So if I had 3 triangles on the inside, like a pentagon that we did earlier, it would be 3 times 180. So if I went down to a nonagon, which is got 7 triangles on the inside, it would be 7 times 180. That's how I got 1,260. So if we're trying to find the angle sum in a general rule, what we'd say is it's going to be the number of sides of the polygon minus 2, which represents how many triangles you can make on the inside, and we're going to times that by 180. And that's going to work every time. And so that general rule really helps us, because let's say we had a 20-sided figure, for example. It would be really hard to draw a 20-sided figure, but we could use our general rule to find the interior angle sum. If we had 20 sides, the number of triangles that you could draw on the inside would be 18 triangles. And then you would just take 18 and multiply that by 180, and you'd find a relatively large angle sum for a 20-sided figure. So the only other idea we have left on this lab is the measure of each individual angle. And if I was going to find that for any sided figure, an n-gon, then I would take what I got for my angle sum and I would divide that whole thing by n, the number of sides and angles. Now it's important to realize that only works for regular polygons. So in the case of a non-regular polygon, you would not know the individual angle measures.